Alright guys, just thought I'd make a video covering the Chapter 8 review. That's for the test that's going to be happening on Tuesday. Alright, so I'm just going to jump in, go through all the problems. So for question number 1, the function v of t is the velocity in meters per second of a particle moving along the x-axis. A x-axis, I like to say. There's just an x horizontal line, and the particle moves left or right, or it can be stopped. And v of t records its velocity along that line. Okay, determine when the particle is moving right, moving left, and stopped. So here's our velocity function. Just as a reminder that on a velocity function, it is moving right when velocity is positive. A particle is moving left when velocity is negative, and it is stopped when velocity is 0. So thinking about what 7 sine of t would look like, if you were to make a small graph of a sine wave, let's call this 7 and call this negative 7. From 0 to 2 pi, this would be pi, and this would be 2 pi. So you can see that this is the velocity curve, v of t, and v of t, the velocity, is positive here, negative here, 0 in 3 different locations, including 0 and 2 pi. So for me, I would just say moving right, this would be on the interval from 0 to pi, not including either of those. It's moving left from pi to 2 pi, and it is stopped. I guess I should be using x and not t. When t is equal to 0, pi, and 2 pi. So that should be everything you need for that one. Alright, problem number 2. The velocity in meters per second of a particle moving along the x-axis is given by the function v of t is equal to 6 cosine of 3t from 0 to pi halves. Find the particle's displacement over the given interval. Now, displacement is just how far away it was from when it originally started. So now it doesn't really tell us where it started, but it doesn't really matter, because all we really need to do to find displacement, so displacement is simply just going to be the integral from 0 to pi halves of 6 cosine of 3t dt. So if we were to take, for example, going back up here, this particle, remember that area underneath the curve is distance traveled, and if the area is above the x-axis, that's distance moved in a positive direction, and area that's negative is distance traveled in the left direction. So if you were to add up these areas, not using absolute values, so using both positive and negative, that will tell you the displacement. It will tell you, so say for example you had this particle on this line right here, and it moved 5 this way, but then it moved 8 this way to the left. Well, the displacement is simply going to be negative 3, because that's how far it is displaced from its original position. And that's what the integral will tell us. The integral will just tell us how far left and how far right and how far left, and it will take care of the in between, or so, if you guys want to call it like that. But simply, it will just tell you this distance right here. That's what the integral will tell you. Total distance would be 8 plus 5. So it went 5 and then 8. So total distance would tell you that. But displacement is just going to tell you how far it is. So all we need to do is do the integral from 0 to pi halves of 6 cosine 3t. So let's go ahead and perform this. I'm going to bring this 6 outside of the integral, so I'll have 6. And then I'm going to take the antiderivative of cosine of 3t. The antiderivative of cosine is going to be sine, so I'll have sine of 3t, but I'm also going to have to divide by 1 over 3 because this has a coefficient of 3. Okay, and then this is going to be from 0 to pi halves. If I can simplify this right here, that's going to be equal to 2 sine of 3t from 0 to pi halves. And then I'm going to evaluate my bounds. So first plug in pi halves. So I'll have sine of 3 pi over 2 minus sine of 0 if I plug in 0. Okay, so this is going to be equal to 2 sine of 3 pi halves. Good thing I have if this were 1 and negative 1, so 3 pi halves would be right here between pi and 2 pi, so it's going to be negative 1. So it's negative 1, sine of 0 is 0, obviously, so negative 2. I guess it's in meters, so negative 2 meters. What that just simply means is that the particle is going from 0 to 2 pi will be displaced 2 meters to the left of where it originally to where it was before that. So yeah, that should be that. Okay, so the function v of t is the velocity in meters per second of a particle moving along the x-axis. Find the total distance traveled. Okay, so the difference between displacement and distance traveled is that, like I gave before, of a particle that might move 5 this way and then 8 from there, the total distance traveled is 13 in this particular instance. And in order to calculate total distance traveled, you need absolute value. So essentially what we need to know when this crosses the x-axis. Okay, so this is a quadratic right here that can be factored into t minus 1 and t minus 2, it looks like. So if we think about what that graph would look like, a quadratic, so we know that it's going to have x-intercepts at 1 and at 2, not to scale by the way, and it's a positive quadratic, so it'd probably be looking something like this right here. Okay, so starting when t is equal to 0, you can see that the particle is moving forward in a positive direction from 0 to 1, and then in a negative direction from 1 to 2, and that's all that we're looking to do from 0 to 2. So the distance traveled here is positive, the distance traveled here is negative, so basically we want the integral from 0 to 1 of this function, and then we want the integral from 1 to 2, but we want the absolute value of that area because we want to add it to this right here. So that's essentially what we want to do. So let's go ahead and roll this out. So we'll do the integral from 0 to 1 of t squared minus 3t plus 2 dt. And then we're going to add the absolute value of the integral from 1 to 2 of t squared minus 3t plus 2 dt. Again, this is going to be, I'm just using absolute value here because I know this is going to be negative because I know the behavior of my function between 1 and 2. It's below the x-axis, so I know that it's going to be negative. Okay, so let's do an antiderivative. So the antiderivative should be, excuse me, it's going to be 1 over 3 t cubed minus 3 over 2 t squared plus 2t. This is going to be from 0 to 1 plus the absolute value. It's going to be the same antiderivative. So t cubed minus 3 over 2 t squared plus 2t, but these bounds are going to be from 1 to 2. Okay, and then let's evaluate our bounds. So by plugging in 1 and 0, if I plug in 1, I'm going to get 1/3 minus 3 halves plus 2 plus the absolute value. If I plug in 0, I'm just going to get 0, so that's why I didn't include that here, so that's why. But if I include my upper bound here, my upper bound is 2, so this is going to be 1/3 times by 8, because 2 cubed is 8. And then I'm going to have minus 3/2 times by 4, since 2 squared is 4, plus 2 times by 2, which is going to be 4. Then I'm going to subtract, now I need to plug in 1 to my lower bound, so subtract 1/3 minus 3/2 plus 2, since if I plug in 1, those are my values, and that's my absolute value. So this is going to be equal to 1/3 minus 3/2 plus 2, plus, I'm going to simplify now, so this will be 8/3 minus 12/2 plus 4 minus 1/3 plus 3/2, and then minus 2. Okay, I'm gonna excuse me, I'm gonna get a common denominator across, so 3 and 2, so it looks like my common denominator across the board is going to be 6. So this should be multiply that by 2, so this is going to be 2/6. Multiply that by 3, so that's going to be minus 9/6. Multiply top and bottom by 6, so that's going to be 12/6. Plus the absolute value, multiply that by 2, that's going to be 16/6. Multiply that by 3, that's going to be 36/6. Multiply by 6, that's 24/6. Multiply by 2, that's going to be minus 2/6. Multiply that by 3, it's going to be 9/6. Multiply that by 6, that's going to be minus 12/6. So that should be equal to, hopefully we got, so negative 2, or 2 minus 9, negative 7 plus 12, so that's 5/6. Okay, plus the absolute value, I'm going to punch that into a calculator, so 16 minus 36 plus 24 minus 2 plus 9 and minus 12, and I got negative 1/6. And so when I add these together, remember that that's an absolute value, so that's 6/6, which is equal to 1. So total distance traveled is 1 for that particle. Okay, now I know what we're all thinking. That's annoying right there. All of that adding, subtracting, it takes a lot of time. It's very, 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 very prone to mistakes because of all the fractions, because of the exponents, because the absolute value, because of the negatives that are happening inside there. So yeah, I'm going to be okay if you can at least show me the correct antiderivative, correct bounds, correct notation with absolute value. If you can at least show me that, then yes, I will be okay. If you show me, if you use a calculator or something to that effect to calculate this right here, you have to be able to know how to do that in your calculator, and you have to be able to get 1 to get the right answer. Okay, I'll try on the test, say for example, if this process is going to be lengthy, tedious, and prone to mistakes, then I'll try and make sure I indicate that it's okay to use a calculator. If, however, I feel like the process is not lengthy and it's not prone to mistakes, and you should be able to do it without making mistakes, and it should be a lot shorter, then I'll try and make sure that I notate in the direction that maybe that you should be able to use it without a calculator. But yeah, for what it's worth, I know that this process is not very nice. Okay, moving on to example 4. So a car accelerates from rest at a rate so a car accelerates from rest at the rate of 1.2 plus 3 square root of t miles per hour per second for 16 seconds. What is the velocity after 16 seconds? So acceleration a of t is equal to 1.2 plus 3 square root of t miles per hour per second. And v of t will be the integral, or I guess we should say v of t. We should say v of 16. So we want to know the velocity at 16 seconds. So v of 16 will be equal to the integral from 0 to 16 of our acceleration function. So 1.2 plus 1.2 plus 3 square root of t dt. And this will, so doing this will get rid of our seconds and leave us in miles per hour, which is what velocity is recorded in, or measured in rather. So let's go ahead and perform this right here. So that's going to be 1.2 t as the antiderivative. Remember that square root of t, so this is 3 t to the 1/2 power. So we'll have plus 3, and then we have to increase that to be 3 over 2, so increase that by 1, so we'll have t to the 3/2 power, but we also have to multiply by 2 over 3 because that's the new power, so that will change our constant right here, and then that's going to be from 0 to 16, so we have 1.2 plus 2t to the 3/2 power from 0 to 16. So let's plug in our upper bound. Oh, I forgot my t right there. 1.2 times by 16 plus 2 times by 16 to the 3/2. 16 multiplied by 1.2. That's going to be 19.2. And then we have plus 2. This is the square root of 16, and that's 4. So 4 to the third, that's going to be equal to 64. And 2 times, so that's going to be equal to 19.2 plus 128. So you add those together, you get 147.2 miles per hour. Okay, so that's page 1. Let's go on to the next page, so number 5. So for number 5, we have a particle moves along the x-axis, units in centimeters. Its initial position at t equals 0 is x of 0 is equal to 11. So it's at 11 centimeters. So you have your line that the particle is moving left and right on. So let's say this is 0. The particle is at, whenever t is 0, it's at 11 centimeters. Okay, and then let's see. So the figure shows the graph of the particle's velocity. The numbers are the areas of the enclosed region. So what is the particle's displacement between t equals 0, which would be right here, and t equals c? Notice that we have a, b. It doesn't show c because the software is unfortunately not the best. So we'll say c is right there. Okay, so displacement. Again, displacement is positive and negative area. So you can see that this area is 10, meaning that this particle moved left 10, okay, and then 17, then it moved over 17, and then it moved over 70. So, but with that being said, the position of where it was is irrelevant. It just wants to know how far away it is from there. So again, minus 10 plus 17 minus 70 should just give us our displacement. So negative 10 plus 17 minus 70, that's equal to, that's going to be negative 80 plus 17. That's going to be negative 63 centimeters. So at t equals c, the particle will be 63 centimeters displaced from where it was. Okay, for nothing below, example 6, the graph of the velocity of a particle moving along the x-axis is given. The particle starts at x equals 8 when t is equal to 0. What is the position of the particle at the end of the trip? So position, so if, let's use this number line that we have up here. So it starts at 8. So what is its position on this line after this travel? So we can see that it looks like the particle moved. So if we calculate the area under each of these are just triangle areas. So it looks like this area is 1, 1, 1, 1, and 1. So the particle appears to have moved 1 centimeter. Are we in centimeters? No, we're in meters. So it moved a meter, moved 1 meter, moved 1 meter, moved another meter, moved another meter. So 8 to 9, 9 to 10. So total of 5. So that should be 8 plus 5. So starting at 8, so plus 5, so it's at 13 meters. Okay. Alright, so that's the difference. So with displacement, it just wants to know how far removed it is from where it was. That's just going to be the total area. And then this is the actual position. So starting from where it was, how many units is it over? Okay, and then, yeah. We have another one on number 8 that's very similar, but I chose to put it here because I wanted to be more efficient with the space of the review. So I'm going to jump to 8 and then I'll go back and do 7 because 8 is more like 6, 5, and 6. So the graph of a velocity of a particle moving along the x-axis is given. The particle starts at x equals 9 when t is 0. What is the total distance traveled by the particle? So again, total distance, where it started is irrelative. We just want to know the absolute value of all area. So let's go ahead and calculate all this area that we have here. So this triangle right here, the area of that triangle is half of its base, which is 1, times by its height, which is 2. So this area is it's negative 1, but the absolute value of that area is going to be 1. Coming up over on the other side, so it looks like we have a trapezoid. So this base has a length of 2, and 1, 2, 3, 4, 5. This is a base of 5 right here. Okay, so trapezoid area is base plus the other base divided by 2 times by the height, which appears to be 2. So it seems like this area is, so we got 7 because those are going to cancel. Yeah, so this entire area is 7. Okay. And then this area, so it's a triangle, so half of its base, which is 1, times by its, its base is 2, sorry, just kidding. And then times by its height, which is 1. So this area is also negative 1. So we want the absolute value. So we want the absolute value of negative 1 plus 7 plus the absolute value of negative 1. So that should be equal to 9 meters that the particle traveled. Okay. Alright, going back up to 7. So midday traffic through an intersection can be modeled by the function 70 plus 9 cosine of t over 5 cars per minute, where t is measured in minutes after noon. Find the number of cars that pass through the intersection. So sounds like we're given a function for the cars per minute. So then if I integrate that function over the given time interval, we'll find how many cars pass through it. So we want to integrate from 0. So since we're between noon and 12:45, and we're measuring in minutes, so we're going to want to do this from 0 to 45. And that's going to be of 70 plus 9 cosine of t over 5 dt. Alright, so let's go ahead and punch that into a calculator. So we got from 0 to 45, we have our function of 70 plus 9 cosine of x divided by 5. And we got 3168 point. We're going to round that up since we don't want to divide cars. So we're going to do 3169. So 3169 cars. Okay. Let's jump down to number 9. So find the area of the shaded region. So we've got 3 different curves happening here. We got y is equal to 5x, y is equal to 4, and y is equal to 1/3 x squared. So if we're going to find the area of this region, we're going to have to split this up. So first of all, I don't assume that that's going to be 1, and you can kind of tell that that's definitely not going to be any of those. So the first thing that we need to do is find where these curves are intersecting. So this is the curve of these two functions. So when does 4 equal 5x? So that's going to be x is equal to 4/5. So that's where this is occurring. And then here, this is when 4 is equal to x squared over 3. So that's 12 is equal to x squared. So that's when x is equal to the square root of 12. So that's where that is happening right there. Okay, so with that being said, I want to find this area right here. So I'm going to need to take the integral from 0 to 4/5, right? From 0 to 4/5, and then we want the function that is above, which is 5x. Subtract the function that is below, so that's going to be x squared, 1/3 x squared, so 1/3 x squared dx. And then for this region right here, I'm going to want to do the integral from 4/5 from square root of 12 of the top function, which is just going to be 4, minus the function that is below it, so 1/3 x squared dx, and add those together. So again, for something like this, it doesn't look like it's going to be very pretty, but I think we can at least find the antiderivative, and then we'll use our calculator. So the antiderivative of 5x would be 5/2x squared, so 5/2x squared. The antiderivative here would be 1/9x to the third, and that's from 0 to 4/5 plus 4x, and then that's going to be the same thing, so minus 1/9x to the third, and that's going to be from 4/5 to the square root of 12. So these aren't very, very nice numbers, and so I'm going to go and plug this into my calculator. Don't be plugging this into your calculator as if you're using the integral function in your calculator. This is what you want to use right here. So we're definitely going to get some not so nice numbers. I can't imagine us getting very nice numbers there anyways. So we'll go from 0 to 4 divided by, I hate using this, 4 divided by 5, and then we have, our function was 5x minus 1/3 x squared. Okay, so 1.5431, so that's going to be this one right here, so that was 1.5431. Okay, so that's what this one is, plus now we need to do this integral right there. So we'll do, we have the integral from, we did 4/5, and then from square root of 12. And then we had 4 minus 1 divided by 3 And I'm missing that parenthesis, 4 divided by 3, x squared, enter. Okay, so that's what we get. So I'm going to take that answer and I'm going to add that answer, 7.6376. Whatever that was, 7.6376 is our answer. Okay, let's try number 10. Same deal, we're just going to be finding the area here. So we want to find this region right here. So good thing here is that it already gives us the intersection. So it looks like we're integrating from -4 to 0 in the x direction. So from -4 to 0 of the function that is above. So in this case, that's x cubed plus x squared minus 6x, and then subtract the function that is below, which is 6x, so minus 6x dx. So this is the integral from -4 to 0 of x cubed plus x squared minus 12x dx. Okay, so antiderivative, that's going to be 1/4 x to the 4th plus 1/3 x to the 3rd minus divided by 2, that's going to be 6x squared. And this is from -4 to 0. I'm going to go ahead and give this a go. If I plug in my upper bound, I'm just going to get 0. So 0 minus, and then I'll plug in -4, so I get 1/4, -4 to the 4th, plus 1/3 times by -4 to the 3rd, minus 6 times by -4 squared. So I have minus, that's going to be positive, and then I'm dividing by 4, so that should be 4 to, that's going to be 64, and then that's going to be -64 divided by 3, so minus 64 divided by 3, and then 4 squared is 16, 16 times 6 is 96, so minus 96, so then I have minus 64 plus 64 over 3 plus 96. If I add those together, that's going to be 32. So 32 plus 64 over 3, multiply top and bottom by 3. So that's 96 over 3 plus 64 over 3, and that's equal to so 160 over 3. Okay, so honestly, I'm kind of on the fence about this one. This one's not that bad of fractions, but also probably pretty prone to mistake because of all the calculations there, especially with 0 being out in front. But anyways, that one's not too bad. Okay, let's keep going. We got 2 pages left, so let's go ahead and get this done. So we have the volume of the solid generated by revolving the shaded region about the given axis. So, and now I'll be honest, I have no idea why this line is here. Same for this one right here. No idea why those lines are there. They have nothing to do with the problem. So if that's on the test, I'll hopefully leave a note about that, but it means nothing. So, so find the solid, volume revolving about the given. So about the x-axis. So this solid's going to revolve this way, and so the solid that it generates will have it will look like that. So it's going to make circular, the cross section will look like that anyways. And so if that cross section looks like that, that's going to be the radius. So the radius will be equal to 4 minus x squared. And remember that for the formula is pi integral from a to b of r squared dx. So let's go. So if we square that, then we get r squared is equal to 4 minus x squared times by 4 minus x squared. So r is going to be r squared is going to be equal to 16 minus 4 minus 8x squared plus x to the fourth. So my integral will be from 0 to 2. I need my pi outside there. Don't forget the pi. And I got 16 minus 8x squared plus x to the fourth dx. Okay, and let's anti-differentiate. So if I anti-differentiate, that's going to be equal to pi, and that's going to be 16x, and then that's going to be minus 8 over 3x to the third plus 1 over 5x to the fifth from 0 to 2. If I plug in 2, I'm going to get pi. That's going to become 32, and if I plug in 2 here, that's going to be 8, and so that's going to be minus 64 over 3. If I plug in 2 here, 2 to the fifth is 32, so 32 over 5, and then I'll subtract 0, subtract 0, because if I plug my lower bound, everything will be 0. So this is going to be equal to pi. I need a common denominator, so I'm going to multiply that by 15 and 15. So that's going to give me 480 over 15. And then I need to multiply this by 5, so 64 times by 5, that's going to be 320 over 15. I need to multiply 32 by 3, that's 96 over 15, and then 480 minus 320 plus 96, 256. So 256 pi over 15. Alright, if you're going to use a calculator, don't forget about the pi. Okay, let's try 12. So about the x-axis, so we're going to find, so same type of problem. Find the volume of the shaded region when it's revolved about the x-axis. So in this case, we're revolving this about the x-axis. Okay, so whenever I do that, I have this region right here, and then I'll have a hollowed out region of that right there. So this is going to be the washer method. So I need the region without that, and then I'll need to carve out the region. So R1 is going to be this distance, so R1 is going to be equal to 2. And remember that for washer section, that's pi integral from a to b of R1. I guess you could say R2. I can't remember what we said, but just in this case, we'll say R1 squared plus the inner one. We'll call that R2 squared dx. So R2 is this distance right here, which is the length of our function. So that's 2 square root of sine x. Okay, so that's equal to R2. So I need to square those. So R1 squared is going to be 4. R2 squared is going to be 4 sine of x. So my integral, I guess I'll keep that there. I should have the integral from 0 to pi halves of the outer radius, so outer radius squared, 4, minus the inner radius squared, 4 sine of x dx. So also, I'm going to factor out a 4. Hopefully that makes it easier. Probably not. But so this would be, don't forget my pi. I need my pi. So factor out the 4. So I have 4 pi integral from 0 to pi halves of 1 minus sine of x dx. Okay, so we have 4 pi, and then that's going to be x, and then that's going to be plus cosine of x for the antiderivative. And this is from 0 to pi halves. And then let's evaluate. So I'll have 4 pi, and then I'll have pi over 2 plus cosine of pi over 2, and then I'll subtract 0 plus cosine of 0. Okay, so I get 4 pi times by pi halves, cosine of pi halves. So cosine pi halves is 0, so plus 0 minus cosine of 0 is 1, so minus 1. Okay, so then I get 4 pi times by pi over 2 minus 1. I'll distribute that 4 pi, so I'll get 2 pi squared minus 4 pi. There you go. I think this is one that you could definitely do without a calculator. Not very hard to plug those in. So just keep that in mind. So doing the same thing, but revolving it about the y-axis. So that's this rotation, so that means my cross-section will look like that. And if that is my cross-section, this is my radius, and my radius should be defined in terms of, it should be x in terms of y. So let's solve this for x. So y squared will be equal to 4x, and x is equal to 1/4 y squared. So that's also my radius, so I need to square that. So my radius squared is going to be equal to 1/16 y to the 4th. So I should take the integral from 0 to 4 because I want to integrate with respect to y. I need my pi, and I'm going to put the 16 out there, y to the 4th dy. Okay, so then that's going to be equal to pi over 16 times by 1/5 y to the 5th, and that's going to be evaluated from 0 to 4. So pi over 16 times by 1/5, and that's going to be 4 to the 5th minus 0 to the 5th, which is going to be 0. So I guess 0 to the 5th, sure. So so I should have pi 4 to the 5th divided by, now 16 is 4 squared. So I'm going to do that so I can simplify this. So that's going to be equal to 4 to the 3rd pi divided by 5. That's 64 pi divided by 5. Okay. Again, that one's not a very bad anti-differentiation one to do by hand. Find the volume of the solid generated by revolving the region about the given line. So the region bounded above by the line. So we're going to need to draw this ourselves. So the line y is equal to 16. So y is equal to 16. Below by the curve y is equal to 16 minus, so it's upside down parabola, vertex up 16. So it's going to look like that right there. So this is y is equal to 16 minus x squared. And then, and on the right by the line, x is equal to 4. Well, so if this quadratic intersects at x equals 4, so it should go up like this. So that's the region that's bounded. And about, and on the right by the line of x is equal, so the region bounded above by the line y is equal to 16, below by the region bounded, so the region is bounded above, right, and it is bounded below this, so below meaning, so this is the region, and it's below, yeah, I think I got that right. So the region is bounded above by this line, is bounded below by this line. Yep. Okay, and it's bounded to the right by, yeah, so we have our region. That should be our region. And it's about the line y is equal to 16. So this is where the rotation is happening. So our object should look something, so let's say this is the x-axis, this is the y-axis, this is the line y is equal to 16. So it should look something kind of like this right here. So that's what our object is going to look like. So a cross section will be right there, and this will be its radius. So that will be its radius. So that distance right here would have to be 16, subtract this distance right there, and that distance is 16 minus x squared. So we'll do, so that's going to be r. So r is going to be equal to 16 minus x squared. So r is going to be equal to just x squared. Yeah. R is going to be equal to x squared. So r squared is going to be equal to x to the fourth. Okay, so I guess I'll just divide like this. Okay, so so we want the integral from we're going to integrate with respect to x, since we're adding our cross sections in this direction and the x direction. So it's going to be from 0 to 4, because that's the line that we went to, x equals 4. And then we need our pi, so we'll put our pi outside here, and then we will do r squared, so that's going to be x to the fourth dx. Okay, so the setup is harder than the actual integral, it looks like. So we'll have pi, and then we'll have 1 over 5 x to the fifth from 0 to 4, so we'll have pi over 5 times by 4 to the fifth minus 0 to the fifth, so it's going to be equal to pi over 5. 4 to the fifth is 1024, so we get 1024 pi divided by 5. That's the volume of that solid right there. Okay, last page, so we're going to go to 15 now. So 15, set up an integral for the length of the curve. So it's not asking you to evaluate, it's just asking you to set up the integral. So remember that the length of a curve is equal to the integral from a to b of the square root of 1 plus y prime squared dx. So in this case, we need to find y prime, so y prime would be equal to 6x to the fifth. Y prime squared is going to be 36x to the 10th. So then my length will be equal to the integral from 0 to 1, because that's the bounds given to us, so the square root of 1 plus 36x to the 10th dx. So that's all we need to do there. Find the length of the curve or non-smooth curve, round to the nearest hundredth. So this, we're actually finding the length here, and apparently we are going to be using a calculator, but we need to set it up first. So and it looks like we're integrating with I think that should be y. That should be y right there, not x, because we're going to integrate with respect to y. Yeah. Yep, because I typed this one in. Yep. And so that should be y. Okay, so we need x prime. So x prime is going to be equal to 1 over 2 times the square root of 1 minus y squared multiplied by the derivative of the inside, which would be negative 2y. So x prime is going to be equal to negative y divided by the square root of 1 minus y squared. Now we are going to square that, so x prime squared is going to be, if we square it, the negative is going to go away. That's going to become y squared, and then this is just going to become 1 minus y squared. So then I'm taking the integral from negative 1/2 to 1/2 of the square root of 1 plus y squared divided by 1 minus y squared dy. Okay, so let's go ahead and put that into our calculator. Okay, negative 0.5 to 0.5. And don't forget your square root, so the square root of 1 plus, oops, don't forget my 1, plus x squared divided by, and we'll do 1 minus x squared, close parenthesis, to enter, we get 1.047. So there's our length. Okay, use L'Hopital's rule. I think that should be capital L, I'm not sure, to find the limit. So make sure that we can get an indeterminate form. So if I sub in 0, I get sine of 0 over sine of 0, which is 0 over 0. So that's confirmed. So then I can use L'Hopital's rule. The limit as x approaches 0 of the derivative of sine 5x, that's going to be 5 cosine of 5x over 10 cosine of 10x, and then I apply my limit, so I get 5 cosine of 0 divided by 10 cosine of 0. Cosine of 0 is 1, so I get 5 over 10, which is equal to 1/2. For 18, using L'Hopital's rule, so if I apply my integral, that's going to be infinity here, and then if I apply my integral here, this is going to be 1 over infinity, so that's going to be equal to 0. So my indeterminate form is infinity to the 0. I'm probably going to add something to this question where I make sure I specify that you indicate which indeterminate form that you arrive at. So I might just make sure you know that so that you can show it. And then here, because it's an exponential, I'm going to use a exponential indeterminate form. I'm going to use a natural log. So the natural log of 1 plus 2x, and then I'm going to drop that power down because it is a natural log. So that's going to be 1 over 2 natural log of x. Okay, which is equal to the natural log of 1 plus 2x divided by 2 natural log of x. And if I apply my limit here, so I'll do the limit as x approaches infinity of the natural log of 1 plus 2x over 2 natural log of x. I'm going to get infinity over infinity because that's just going to keep going to infinity. Okay. So now we'll do L'Hopital's rule. So the limit as x approaches infinity, the derivative of that is going to be 1 divided by 1 plus 2x. I need to multiply by 2 because of the chain rule, so that should be that. And then divided by the derivative of that, which will be 2 times by 1 over x. Right? 2 times by 1 over x. Yeah. Okay, so I'm going to use keep change flip, so the limit as x approaches infinity of 2 over 1 plus 2x times by x divided by 2. Those are going to cancel, so I get the limit as x approaches infinity of x over 1 plus 2x. And if I apply my limit, I'm going to get infinity over infinity. But then I can use L'Hopital's rule again. So the limit as x approaches infinity, I'll have 1 over 2, and that's just going to be 1/2. Now remember that I still need to do one last step, and that is I need to do e to the, so my limit of my original function before I took the natural log. So the limit as x approaches infinity of 1 plus 2x raised to the 1 over 2 natural log of x is equal to e raised to the 1 half, which is what we had here. So e raised to the 1 half. So that's our solution there. Okay, last two problems. All right, so evaluate the improper integral or state that it diverges. So let's set up the limit. So the limit as t approaches negative infinity, the integral from t to negative 2 of 4x to the negative 5 dx. Okay, so my antiderivative, this is going to be equal to the limit as t approaches negative infinity of, that's going to be x to the negative 4, so I divide the outside by 4, which will be, so negative 1. And then that's going to go from t to negative 2. Plug in my bounds, so I get the limit as t approaches infinity of negative 2 to the negative 4 plus t to the negative 4. Right, okay. So that's equal to the limit as t approaches infinity of negative 1 over negative 2 to the 4th plus 1 over t to the 4th. So that's going to be equal to the limit as t approaches infinity of negative 1 over 16 plus 1 over t to the 4th. And as I let t go to the infinity, that's going to be equal to 0 right there. So I'm going to get negative 1 over 16. All right, so for 20, we're going to do the integral from negative 27 to 1, and I have dx over x squared over 2/3. Now, this cannot be equal to 0, and 0 is in between negative 27 and 1, so that will definitely result in an asymptote, and we can graph it to make sure. If you need to graph it to double check, I think we should be right there. So x cannot be equal to 0, so we'll do the integral from negative 27 to 0 of, we'll call it x to the negative 2/3 dx, and then we'll add the integral from 0 to 1 of x to the negative 2/3 dx. Now, since this is approaching infinity, we need to write it as a limit. So the limit as t approaches 0 from the left of the integral of negative 27 to t x to the negative 2/3 dx plus the limit as t approaches 0 from the right of the integral from t to 1 of x to the negative 2/3 dx. Okay, so I have the limit as t approaches 0 from the left. So I need to add 1 to that. So that's going to be x to the 1/3. I need to times by 3 then, or divide by 1/3, which would just be times by 3. And this is from negative 27 to t. And then plus the limit as t approaches 0 from the right of the same thing, 3x to the 1/3. This is going to be from t to 1. So I have the limit as t approaches 0 from the left of 3t to the 1/3 minus 3 negative 27 to the 1/3 plus the limit as t approaches 0 from the right of 3 times by 1 to the 1/3 minus 3 times by t to the 1/3. So then I get the limit as t approaches 0 from, we can just go ahead and plug in 0, honestly. So if I plug in 0 here, that's going to go. Plug in 0 here, that's going to go. So I'm just going to get negative 3, and the cube root of negative 27 is negative 3. And then I'll have minus, or no, just plus 3, because 1 to the 1/3 is 3. Again, that's gone. So then I get 9 plus 3, which is equal to 12. Okay. There's an answer key if you need it. Okay, it should be on the PDF, and that should complete the review. Let me know if you have questions. Thanks, guys.